Hello, my dear student. Today, let us talk about the vector field of a given differential equation. Okay, so every differential equation cannot be solved, even though, according to the existence and the uniqueness theorem of the differential equation of initial value problem, theoretically, existence and the uniqueness is guaranteed, but in practical we cannot solve it. We cannot solve it, but we can use computer and we can find out the approximate curve by finding out the vector field. Okay, so let us see. The basic idea is that when we talk about differential equation dx dy, so it is dy by dx or dx by dt. Okay, dy by dx or dx by dt. The right hand side is a function of the dependent variable and independent variable. Okay, so in the last class what we talk about is that if this function satisfies certain conditions, then the existence and the uniqueness, okay, of the solution curve passing through the initial point is guaranteed. Even though the conditions are fulfilled, sometimes we may not be able to find out the solution, because every differential equation cannot be solved. That is quite clear. Every one of you know every differential equation cannot be solved. Okay, but one thing is very sure here, dx by dt, so the solution will be a curve x, some function phi of t, and the parameter initial value will be involved there. So the solution is a curve x is equal to phi t something, okay, like that. So then this dx by dt, from elementary calculus we know that what is dx by dt. Suppose in that point, initial point, in this function you put the value of the point t and x and evaluate the function, you get a point, and that is equal to dx by dt. And this dx by dt in that curve is a tangent. Okay, it is a tangent. All right, the slope, this will give you the slope at that point through the curve. Okay, so then if you get some numerical value there here, then you find out the tan inverse of that one, you will get some angle. So that is the direction, that is the vector field direction of the tangent at that point through the curve. Okay, so tangent to the curve at that point, this will give you. So suppose if you understand in all possible points, this thing can be found out easily using this function. This function is known. So this, by taking different point, you can evaluate this function, and that is the slope, the slope. So then at each point you can think about, in the xt plane, at this point you can think about some direction field. That direction field is the direction of the tangent to the curve at that point. So if you know the tangent direction to the point, okay, so in the neighborhood, in the near point also, you find out like this all the tangent field, tangent vector. Okay, then you can roughly draw the curve. All right, so even though if you are not able to find out the solution, okay, existence is there, but you cannot solve it because differential equation cannot be solved sometime. Okay, but using this method, using computer, you can roughly find out the solution curve. Okay, that is the whole idea of this lecture. Okay, so first let us see some fundamental solution, how the solution behave. Let us see. So the basic thing is that we want to find a solution curve passing through a given point. Okay, we want to find a solution passing through this point. Suppose all the conditions fulfill, all the condition of existence in a uniqueness fulfilled, and then let us try to find out the solution passing through this point, because time is never negative, so time start from 0, but therefore let us, for the time being, let us start from the time 0. This is the initial point, and suppose when time is equal to 0, x is equal to x naught. Let us see, x is equal to x naught. Okay, then the solution, let the solution be, solution will be function of t. The solution will be like this, x is equal to some phi. All right, so this x naught will be a parameter here. So by, for notational convention, let us write, let us write this one as like this. Okay, just instead of writing here, let us just write here phi t x naught. Then when t is equal to 0, when t is equal to 0, what is the point? This is a solution, means what? When you differentiate this with respect to t, you will get this one. Okay, all right, and this solution passes through this one, which is what? When you put t is equal to 0, x should be x naught. So when you put here t is equal to 0, x naught should be, this one. Okay, so by our notation, then this is like this. Okay, so this is a solution. All right, and then let us see, the solution is a curve in the xt plane or tx plane. The solution is a curve in the xt or tx plane. All right, so this is time axis, and this is your x-axis. All right, so for example, say in the population model, so x will be the population and time t is the time. Okay, then you want to find out the population of some species at any time, the rate of change, that is differential derivative that is given by the equation. Okay, so just simple model like that. Okay, so we want to find out the curve. Suppose the solution curve is like this, passing through, suppose the solution curve passing through this point x naught when t is equal to 0 is this one. This is your solution curve. Okay, and then after time has lapsed by a unit of t1. Okay, when times comes here, a unit of t1 time here, this is time 0 and this is time t1 unit. Okay, so from the curve, your this x naught original position moves this here. Okay, so moving, that is dynamics. Okay, it is moving here. All right, so and according to the from the curve, this point is what? T1 and phi t1 x naught. Okay, so that means this is your starting point. Along the curve after t1 unit, you will be here. Okay, you will be here, or along the x-axis, along this axis, you will be here, and this is your point. Okay, this is the point here. Okay, suppose this is your phase space x. Okay, so it will be here. All right, and this is also a point in the x plane. According to the existence and the uniqueness theorem, starting from here also, you can think about one solution. Okay, all right, at every point, if the two conditions are fulfilled, there will be one solution. Okay, so this is another starting point. You think about it, is another starting point. Okay, this is starting point. All right, then after, from here, after s1 unit of time, where will be the point? It will be here, according to the solution. No, after t unit of time, t x naught, this is the initial position. Okay, now this is regarded as an initial point, that is, this is your initial point, and then after s1 unit, you will be here. After s1 unit, you will be here, s1, and the initial position, this is the initial position here. Okay, so this initial position after s1 unit, it is here. So according to this notation, this is how much? According to this notation, this is phi s1 and phi t1 x naught. Okay, all right, so then again here, from here to here t1 unit, and from here to here s1 unit. Then starting from here to here, how much time? is there, t1 plus s1 unit of time left, okay, from here to here. So then starting from here, after t1 plus s1 unit of time, okay, again starting from here, after t1 plus s1 unit of time, you will be here again, same point here, okay. Starting from here, you will be landed here, and after starting from here, after t1 plus s1 unit, you will be landed here. So this point is same, okay, this point is same. All right, that means what? You think about this as an initial point, is think about one solution curve, okay. All right, so after t1 plus s1 unit of time, it will be here, and then you think this is an initial point, and after t1 unit, it will be here. Then again, lastly, you think about this as an initial point, after s1 unit of time, you will be here. It's the same point will be here, okay. So then these two are equal, these two are equal. So what does it say? This solution says that you take this as initial point after t1 plus s1 unit of time, so this is the point, okay. Starting from here, after t1 plus s1 unit of time, this is your point. So by notation, this is equal to this one. And what is this? So what is this? This says that think this as a initial time, after s1 unit, you will be in this point, okay. This point is exactly equal to this point, okay. So starting from here, after s1 unit, you will be here, but starting from here, after s1 plus t1 unit, you will be here. So you move from this point along this curve, so you will be landed here, and then from here again you start, and then you will be landed here, okay. So this we call it, this is called trajectory. The curve, solution curve, is called trajectory. As t varies, the initial point moves along this, you know, you can think about like that. The initial point x naught will move along this curve, or dynamics changing, dynamics something changing, okay. As t varies, okay, this initial point moves along this, you know, curve. So in terms of orbit, you know, in terms of orbit, x naught is a orbit point, and this is also another orbit point. So lots of set of this set of point is called orbit, and this we call it trajectory. So trajectory and orbit are almost similar notions, okay, similar ideas, okay. So like that. So such function, okay, such function phi, we call it flows and dynamical system. Some author will use flows instead of using dynamical system, okay. This function satisfy this rule, okay. One more thing is that the, you know, identity function, okay. So when x you are talking about the initial position x naught and a time 0, na? So you put 0 here, then you will get initial position, okay. Then this phi naught can be regarded as a identity function, because its image on x naught is giving same point x naught, okay. So identity function. So this condition fulfill along this, you know, this condition fulfill, this equality fulfill, that type of function we call it what? Flows. So dynamical system, another language, many authors use flows also, okay, flow. So this is similar with the discrete dynamical system we did in semester 3, you know. The n plus m orbit member of this point, it is this one. So this is equal to what? If you start, this is the initial position, okay, the nth orbit member, start from here, the nth orbit member of this point is equal to the n plus m orbit member of this point, okay. So this equal to is, this is the analogy of the discrete dynamical system. This is discrete dynamical system why the time you can take discrete value 0, 1, 2, 3 like that, okay. So in invertible dynamical system you take -1 also, -2 also like that, okay. But here the time can take the values continuously, or the whole interval of positive positive real axis, non-negative real axis including 0. Okay, that is why it is called continuous dynamical system. So continuous dynamical system means differential equations are involved, solution of differential equations are involved. Therefore you have to be very good in solving differential equation also, and properties of differential equation. Okay, so this is the idea of the solution curve or trajectory orbits of the continuous dynamical system, some basic idea. All right, so now let us go back to the vector field. Now let us go back to the vector field. So in the last class we talked about the solution of this differential equation. Okay, existence and the uniqueness of the of this type of differential equation. So vector field, as I mentioned earlier in this lecture, what is dy by dx? Solution will be a curve y is equal to some phi x, and dy by dx is a slope. Okay, dy by dx is a slope of the curve at that particular point. Okay, so and let us see. Then you try to draw the you try to draw the vector field. Let us see some example. Okay, here you take different value x, y. So here I am taking x is equal to 1, y is equal to 1. What is minus x by y? It is minus 1. So tan inverse of minus 1 is 90 degree plus 45 degree. All right, 90 degree plus 45 degree, and that is the direction of the tangent. Okay, and when you take x is equal to 1, okay, you take y is equal to 2, this is minus half. Approximately this is some 26 degrees, some fraction is there, so I am approximately taking it 27 degree. 90 degree plus 27 degree will be there. Okay, so then let us see. This is this is your x-axis. Okay, this is x-axis, and this is your y-axis. So this is xy plane, and the solution curve of this differential equation will be a curve on this xy plane, and that is a function of y, some phi x. Okay, so in this particular point, suppose you don't know the curve, but if you know the direction, you can roughly sketch the curve. All right, at this particular point, this is 1, x is equal to 1, y is equal to 1. What is the degree? It is 90 degree plus 45 degree. So 90 degree plus 45 degree, but this we all know that 90 degree 45 degree is what? So if you draw this one, so this if you draw here, so this will be 45 degree. So then if you put 90 degree from here, so the direction will be in this direction. Okay, so direction will be in this direction. So this is 45 degree plus 90 degree, so direction will be in this. So the solution curve at this point, its tangent vector is in this direction. Okay, so if you know the tangent vector at each point, then you can roughly sketch the solution curve. Okay, so then again, suppose here again, what is this point? This is x is equal to 1 and y is equal to 2. So when x is equal to 1, y is equal to 2, what do you get? Minus x by y is equal to minus half. So tan inverse of minus half is approximately 90 degree plus 27 degree. Okay, so let us see. 27 degree roughly, you can do it. 27 degree will be roughly here. It will be less than 45 degree. Okay, so this is 45 degree, it will be less than 45 degree. So from here you put 90 degree, so direction will be here. The vector field direction will be here. Okay, so this will be 90 degree plus 27 degree. So that means what? At this point, the curve has this one as a tangent. Okay, so like that, at every point you think about drawing such vector field. At each point you think about drawing such direction. Okay, so that is easily, because why? Even though you cannot solve the differential equation, you know this function. Okay, so you know this function. By entering the values of x and y, you will be able to find the value of this one. So tangent inverse of that one is just some degree. That degree will give you angle. That angle degree will give you the direction of the tangent to that point. Okay, on the curve. All right, so then roughly you can sketch the direction, the solution curve. Okay, so once if you establish the solution curve, you will understand lots of behavior of the dynamics. You can understand it. The thing is that we want to find out the solution curve. Some differential equation can be solved easily, and then you find a curve and you study it. Some differential equation, even though the existence and uniqueness theoretically is there, but you cannot solve it. So in that way, vector field helps you a lot. So at each point you can draw the direction. Okay, the set of such direction we call it vector field. Okay, so in examination also I can ask you to do some some plot, some few point by giving you few points. Okay, 10 points, 15 points, like that. So then you have to find out the angle and then direction to that point. So that is the direction of the tangent vector through the point on the curve. Okay, so let us see. I'm having here some online resources. I will show you how to draw some vector field. So for this one, let us see for this one. So these online resources you can also do. So here minus x by y, dy by dx is equal to minus x by y. So this is this is the vector field at this point. So here here at this point, see, at this point, suppose here, okay, at this point you have direction field here, direction field. At this point you have direction field. Okay, at this point you have direction field. Suppose in examination I can ask you, in the unit of 1, 0, 1, 2, 3, you have to draw the direction field by calculating all those angles, like that. Tangent inverse of dy by dx is angle. The angle, if you have the angle, you can draw this direction field. Okay, if you have the angle, you can draw this direction field. Just now I have explained you how to draw the direction of 90 degree plus 45 degree, 90 degree plus 27 degree. I have roughly told you. You can watch that video again and again, and then so for any other point also you can find out the direction field. Okay, so this is the case when dy by dx is equal to minus x1. Then so let us see, suppose the passing through this one, what is the solution curve? Just click here. So this software is very interesting. Passing through this one, let us see what is the solution curve. See, circle. Okay, one circle. I have clicked double time 2 times, and that is why we are getting 2 circle. All right, so let us see here, passing through this one, what is the solution curve? See, so it is a set of circle. Okay, yesterday also we have done that one. So vector field is, so from looking at the vector field, you can roughly see the sketch of the solution curve. If you know the solution curve, dynamics is over. One way you can say that dynamics behavior, how the point moves in the in the space. That is all about dynamics. From this it goes to this point, like that. Okay, so finding the solution is very important. Sometimes we may not be able to find a solution, but using the vector field method you can roughly sketch the solution curve. Okay, so let us see another example. Let us see another example. Suppose I am entering here some function. So this is x square plus y square. Let us see this function, x square plus y square. So f of xy is equal to what? Dy by dx is equal to f of xy, and here f of xy is equal to x square plus y square. Okay, x square plus y square. All right, so this one, this function satisfy both uniqueness and existence and a uniqueness condition. Okay, at each point this function satisfy existence and a uniqueness condition. but you already know that this simple differential equation cannot be solved by separation of variable, all this type of thing you use, whatever method you have, you cannot solve it. But using vector field idea, see, the vector field of this differential equation is like this. In this space, in this space, x is from -3 to +3 and y is from -2 to +2 in this area of this xy plane. So in this gap of this unit, you find out the vector field. Okay, so at this point, the direction, so at this point the direction of the tangential vector is in this way. All right, so like that. So if you know the vector field, roughly you can sketch the solution curve. So although this solution cannot be solved, but using this computer technology software, we can roughly sketch the solution curve. Let us see. Suppose here, suppose at this point here, what is the solution curve? Just click here. It will give you, the software will give you the solution curve. See, the solution curve is like this. So, and again here, passing through this point, what is the solution curve? Let us see. See, the solution curve is here. All right, this is the solution curve. Now let us see here, what is the solution curve passing through this one? See, this is the solution curve. Red is the first one, green and yellow. Okay, let us see here again, what is the solution curve passing through this point? It is here like this. Okay, so using the vector field idea, so what is vector field? I told you, at this point of the space xy plane, at this point you put the value of x and the y in the f of xy, in the given differential equation, dy by dx is equal to f of xy. That will give you some numerical values. Tangent inverse, tan inverse of that value will give you direction. Okay, angle. So at that point you have some angle, you draw some angle. So this is the direction. Okay, this line, small line segment, is the direction. Okay, so what is the direction? It is the direction of the tangent vector at that point on the curve. Okay, so this is the direction of the, at this point, this is the curve. At this point, the tangent vector, the direction of the tangent. Okay, so if you have the tangential direction, you can roughly sketch the curve like this. So this is, we call it vector field. So let us again see, very interesting here, what is the solution curve? Just click here, using this software you will get solution curve here. See, all right, at this point solution exists, and it is unique also. There is no two solution, one solution is there, one and only one solution is there. Let us see here. See, this is yellow curve. Okay, so this is how you can do it. You can use this software. This is free software, there is no copyright issue here. You can click here, what is the solution curve? It is almost vertical line here. See, it is almost vertical line here. So nearby here in the zero, you have some curvature type of curve here. Okay, so this one, and then let us see another example. Let us see another example. Suppose the function is x by y. When the function is minus x by y, that is solution curve is circle. Okay, when the function is x by y, the solution curve will be hyperbola. Let us see, let us check it. Okay, so you enter here x divided by y. Okay, let us see. First you clear all the ground. So this is the vector field. At this point, small vector line segment are drawn, and they are the direction of the tangent at that point on the curve. Okay, so this is the see x by y. When dy by dx is equal to x by y, you can solve it easily. This one you can solve it by separation of variable, and you will get family of family of hyperbola. So let us see the graph of the hyperbola at this point. Suppose at this point graph of hyperbola, see. So another counterpart will be here, hyperbola, see. Okay, and then at this point what is the hyperbola, see, and here also you can see. All right, at the origin, the when y is equal to 0, when y is equal to 0, according to the existence and the uniqueness theorem, the function fails to be continuous. Okay, function, so therefore uniqueness is not here. So there are two solutions. One is this line, another is line. They are crossing here. Okay, passing through this point, there are two solutions. Okay, see. So passing to this point, there are two solutions. All right. So uniqueness is not here. All right. At any other point, you will see only one curve pass through that point. Okay. Only one curve pass through that point. All right. Okay. So this is the thing. You can enter different value of the function, and then you can draw graph like this. So this can be, I am thinking about giving you some project, because now we are not able to do regular classes. I don't think we will be able to do some unit tests also. So better to give you some project type of thing. I will give you later on. I will give you some function and to draw the vector field, and then to draw the graph. Okay, so that you can use this software. So you can go to the name of the website or something like that. I will give you in the this one WhatsApp group also. Okay, just type in Google slope and a direction field of differential equation. So there are lots of software, free software. You can use one of them, and I find this one is very interesting. But this is very small. You may not be able to see it correctly because it occupy only some space of the whole desktop. Okay, so anyway, you have some idea, you can go to the Google. And so let me tell you again, you just type in the Google slope and a direction field, and there are lots of online software is there. So you can just click there and enter the value of the function and try to draw the vector field and the corresponding curve. Okay, so now let me close here. This was some fundamental. These are very fundamental things. Understanding it's very important, and later on you can easily understand what I am talking about. It's a vector field, solution curve, all these things, existence, uniqueness. Okay, so these are very fundamental thing. I will give you some project type of thing for unit test. Okay.